Welcome back, third grade scientists. Today, we are going to explore an experiment with light to go along with your lessons this week in the human senses and movement. So let's get going with this fun, easy experiment that you can do right at home. I'm sure you have the materials to do this experiment today already at your house. Let's get going. Okay, so first, let's talk about the science of light. In this experiment, we are going to explore the question, why is the sky blue? Haven't you always wondered about that? Why, when you look up at the sky on a clear day, is it the color blue? A lot of people may have given you a lot of different theories about why this is true, but now, after today's experiment, you're going to be able to explain the science and the truth about why the sky is blue. It all has to do with the science of light. The colorless light that comes from the sun is actually white light. And white light is made up of all the rainbow colors mixed together. Light bends when it passes from one medium into another medium of a different density, in other words, a different thickness. And this bending of light is called refraction. Different colors are refracted by different angles because they have different wavelengths. So when white light gets refracted, that's when you see the separation of colors in a rainbow. And as a result, when the white light is refracted, it is separated into the different colors known as a dispersion of light. A rainbow is a perfect example. So let's see how that makes a connection to why the sky is blue. Well, the sky is blue because of something called Rayleigh scattering. What is Rayleigh scattering? In the air, there are many tiny air molecules. These molecules are very small, so small that we can't normally see them with our bare eyes, even though the air is full of millions and billions of them. On a very clear day, sunlight passing through the atmosphere is scattered by air molecules. Remember that refraction and the dispersion of the colors? This scattering effect is called Rayleigh scattering. Scattering is stronger with shorter wavelengths. So among the visible colors in the rainbow, the blue-violet end of the spectrum has the shortest wavelengths. And although violet is scattered more than blue because its wavelength is shorter, our eyes are actually more sensitive to blue than violet. And that is why the sky is blue during the day, because of this example of Rayleigh scattering. The sunlight going through the air molecules, going through that refraction, and the colors being dispersed, being that blue violet has the shortest wavelength, that's the color we see the easiest. And we actually see blue easier than violet because our eyes are more sensitive to blue. So it gets to our eyes the quickest. So let's do an experiment and see how this works. Why is the sky blue? We'll find out with this fun and easy experiment. You will need a clear drinking glass. Fill that glass with some water. You need milk, but really only a drop, and a flashlight. The best kind of flashlight to use is one that gives off that bright, clear white, like an LED flashlight. That will work the best. You will also need to do this in a dark room. So here's how this experiment works. First, you're going to fill your drinking glass with water. Then you're going to add milk to the water to make it a cloudy solution. You really only need a drop of milk. Actually, don't put too much in. The less you put, the better this will work. You're going to take your glass now with this cloudy solution, and you're going to go into a dark room and point the flashlight at the cloudy solution from the side. So since this room really isn't dark enough, you're not going to be able to see it so well in this lighting, but when you try this at home, you're going to go into like a dark room, like a bathroom or a big closet, someplace that's not too bright without a lot of sunlight and where you can shut off the lights. So your glass should look something like this. So I filled my glass with water and I put in really just a teaspoon, like a tiny amount of milk, just to make this cloudy solution. Then I chose this flashlight because it has a bright white light. You're going to take the flashlight and you're going to put it against the side of your solution. So right now, because this room is bright, it looks like it's glowing white, but you can kind of see where the light meets the milk. You can see a blue light coming out of that, can't you? That's the effect of the Rayleigh scattering and why the sky is blue. When you take this into a dark room, you should see more like what's in the photograph. Look really closely at the side and be sure to point your flashlight through the side of the glass, not through the top, but through the side. Actually, this is working better than I thought because you can see that refraction of light coming back at you in a blue color. Observe the fluid from the side to see a hint of the sky blue color. It's not going to look as full and as beautiful blue as this photo. You will have to look closely to the side to see that blue color, but it will be there. And the reason why your white cloudy suspension turns blue is similar to the reason why the sky is blue. Like sunlight, the white light from the flashlight is also made up of all the rainbow colors. Therefore, the blue light, which has the shorter wavelength than most of the other rainbow colors, is scattered more, and that's why your cloudy solution looks blue like the sky. Give this a try. This is a really easy and fun experiment to do at home. Great job. Keep up the great work. They're great scientists. It's always fun doing new experiments with you.